Simon Boyden, Chief Architect for IBM's work at Wimbledon, will now speak about the ways in which IBM puts artificial intelligence and machine learning to use to create amazing fan experience for the Wimbledon Tennis Championship. Simon is joining us online. Simon, yeah, I can see you now, so please take the screen.
Thank you very much indeed. I'm hugely excited to be here. Very sorry that I can't be here in person, but it's great to be talking to you all. And I'm hugely proud of the role that I do and work with IBM's work at Wimbledon. So it's a topic that I love talking about and one I'm very passionate about. So as the title says there, I'm responsible for all of the on-site technology work that we do for IBM's relationship with Wimbledon. And you know, the relationship that we have with Wimbledon is really a unique one. So you know, we have been doing this for the last 32 years. So IBM's relationship with Wimbledon goes all the way back to 1990, and we have done a whole variety of different things for them. We'll talk about that a little bit on, but all of this is about a genuine partnership, and it's different than a lot of the other clients that I work with in my consulting background. As a technical leader within IBM, it is a genuine partnership about working out how IBM and Wimbledon together can create some of those amazing fan experiences. And Wimbledon as a championship, as a tennis tournament is unique. Wimbledon itself is a private members club with only a few hundred employees, and yet for 2 weeks of the year, the eyes of the world are on SW19 and the tennis that is being played. And Wimbledon lives and dies by its brand. The way that it makes money is by TV rights, by sponsorship, which are all integrally built into the brand that Wimbledon has. And what we try to do is to work with them to elevate that brand through technology and through innovation. And as I said, this is something which we've been doing for the last 30 years. And this goes all the way back to, building a website for them in 1995, where you can see we have the grand total of 200,000 visits. We have tens of millions of visits now. Likewise, all the way back in sort of 2002, we were putting little PDAs in the hands of some of our partners who were there. Using things like GPRS technology to stream updated technology, things that at the time were a long way ahead of their time. But what has been a continual theme of this is innovation that is right for Wimbledon at the time. And over the last 5 or 6 years, that has meant two things really. One is cloud and one is AI. And it's really some of those AI stories that I would like to talk to you about today, and to kind of give you a flavor about how we bring some of those technologies and techniques to play at Wimbledon. Before I do though, because we cannot do anything about this until we have the data, and I'm sure I'm preaching to the converted amongst this audience here, and understanding that we cannot do any of these technology smarts without getting that core data. And for us, that's about establishing real-time data-driven content. And you're going to be surprised, because the start of this story is not about applying AI learning and machine vision to the problem. It's actually about putting man and machine together. So we recruit around 48 tennis statisticians. So these are really good tennis players, so county level tennis players in the UK. We've had some of these folks going on to play in elements of the Wimbledon Championship. And we use these people to capture all of the data about every single point that goes on at the championships. And some of this is stuff which absolutely you could automate. Was it a forehand? Was it a backhand? But a lot of the actual information and stuff that we're capturing, things like, was that a forced error or unforced error, is all about understanding the game, about being able to read the game, about being able to understand some of those finer nuances. So we actually start with people. We capture the data, we target 100% accuracy on that. We try to do that in sub-second. And that is because, when you're watching the TV, the statistics that you see on the BBC in the UK, on ESPN in the US, are all driven from those statistics. We want to be able to kind of do that quicker than anybody else. We want to be able to do that with absolute accuracy. And we are on a learning curve about how we can apply AI and machine learning to it. But it's a really great example of actually of a situation where to do this to the standard that Wimbledon drives actually doesn't work yet with AI. But I'm going to be delighted to talk to you about some of the scenarios where we can apply a lot of this information. So to give you some context about what we do, we have all of that news, scores, information. We take feeds from partners such as Hawkeye, who do ball and tracking. And essentially what we have is a really big content delivery and enrichment infrastructure. So this is content which is written by journalists. This is all of that statistical information that we gather. We apply that through all of our analytics and our cognitive services, which we'll talk about later. And broadly, these go to three main groups. So first was that TV audience we see. So all of those insights and statistics get shown to that global news audience, wherever you are in the world. We deliver this information to on-site fans through screens, but recognize that actually only about 500,000 people can make it through the grounds at Wimbledon. We have a huge number of media who come on site, and obviously last year with COVID, we're working remotely as well. So we make all of this news and information and insight available to the media, and of course then to people who consume all of this through our digital channels, through mobile, through web, through social. Tens of millions of people who aren't able to come on site, but for whom we want to be able to create some of these insights and these stories. And to recognize that, Wimbledon's done some really interesting research on this. Not everyone who comes and watches tennis at Wimbledon, who turns on the TV, who logs onto the website, are tennis experts, far from it. A lot of people tune into Wimbledon because they love the experience, the tradition, the history of it. Maybe just because they want to see who the celebrities in the Royal Box are. So what we're increasingly trying to do is to use AI and technology to help tell the story of tennis for those fans. And one of the ways we do that is through these digital channels. So we create things, we create things across mobile, across web, across other channels, and really try and give a sense of what it is like to be at Wimbledon. These are very visually intensive sites, really trying to create that piece, because at the end of the day, that brand of Wimbledon, English in tennis in an English garden, is what we're trying to show. But it's fair to say that we, working with Wimbledon, have some real challenges. Challenges that are common to all of the sports. Consumption is increasing. We're spending more and more time in front of screens, but actually, in many cases, that appointment to view is something which is decreasing. Wimbledon is very lucky that probably the ladies and gentlemen's finals are some of the few events where people do genuinely sit down at the same time in the afternoon in front of a screen and watch live sports. But across the rest of the championships, that is absolutely a challenge. We see competition from a lot of other sporting venues and sporting events. So every 4 years we have the Olympics, we have the Euros football. Quite often the British Formula One Grand Prix comes out at the same weekend. And tennis as a sport, of course, is at an inflection point. In the ladies' game, I think we're in. We feel like we're starting to pass that place, with people like Coco Gauff and Emma Raducanu creating a huge amount of excitement in the game. Every time I give this presentation, I talk about the men's game and the fact that surely we must be approaching a point where the likes of Novak Djokovic and Roger Federer are going to pass. And every time it goes, we're not quite at that point yet. But it means we have a lot of challenge, and that means we are operating in a very crowded environment. It means that we're trying to take content and repurpose it in different ways that support the different consumption habits of our fans. And we've done a lot of work looking at the numbers. So tennis has a rich set of statistics. You only need to listen to the TV and hear commentators talking about first serve percentages and second serve percentages and unforced errors. And there's a lot of work that we've done around that. Providing up-to-date, second-by-second, point-by-point tracking. We have something called IBM Slam Tracker, which uses a lot of more traditional data analytics and insight to understand what are the real important factors in winning a game, and to try and explain that to the fans. And things like looking at real-time alerting, trying to understand characteristics of games to provide alerts and notifications of excitement and interest. But I guess the lesson that we've learned through this was that there is only so far that you can get from looking at statistics, because they only tell one dimension of the game, and they tell quite a sort of a scientific, dare I say it, sort of tennis nerd angle on the game. So what we started to realize was actually we've got a huge amount out there in terms of video and audio content that we really hadn't been mining, and that was the insight that led us to a lot of the work that we've been doing over the last few years. So I'm going to start kind of going into a specific use case, and this use case is a real one for Wimbledon, which is you have a tennis match which may be 2 hours, it may be 4 hours, it may be 10 hours long, to take an extreme example, with hundreds and hundreds and hundreds of tennis points. And how do you understand what the most exciting points within that game are? You might want to do this because you may want to create kind of an automated highlights package. So you might want to say, you know, I want to summarize this 3-hour match down into a 30-second clip of video. If I'm a social editor, I want to be able to understand, you know, perhaps what's the most exciting point in the game, in the match, that I can sort of put out on an Instagram or TikTok feed. I want to be able to understand what's going on. And traditionally, the way the club had done that was to have video editors who would sit and who would watch the game, who would identify the points, who, you know, to make a highlights reel would manually kind of chop the video up and do that. And I guess the question we had was, could we do better than that? Could we teach, and this is kind of coming back to the title of this, you know, could we teach computers to kind of get excited about tennis? What makes an exciting tennis point? And again, the insight that we had around this was that if you or I were sitting and watching a game of tennis, you wouldn't need to look at the statistics. You wouldn't need to look at first serve percentages or anything like that to know whether you've just watched an exciting point. And the reason for that is the crowd would be going wild. There would be shouting, there would be cheering, there would be clapping, and likewise the players themselves would be reacting. There might be fist pumps, there might be kind of, you know, look up to the skies, or in the other end of the scale, you know, there may be heads down and disappointment. So what we did was two things. One was we created an AI model for cheer recognition, and this is actually an area that we hold a number of patents around. So we created that model that could listen to the audio track, could pull out what the sound of an excited crowd looked like, training that on some of our existing video footage. And we also did a similar thing around action recognition. So we wanted to understand the reaction of the players, not in terms of kind of detail of facial recognitions, but more in terms of kind of body pose and things like that. We combined that with all the statistical data that we had from the left-hand side of this picture. So all of that statistical information, you know, we know that break points are exciting. We know that when the momentum of a game shifts, that's exciting. And what we were able to do was to put that together into a essentially excitement rating for a point. We had to apply some techniques to avoid bias in that AI. So, you know, classic kind of thing of a British player who's just who's having an amazing game on centre court. Of course, they will always get the cheers. They will always get the recognition from the crowds. You know, likewise, big match has just happened. Frankly, a lot of the crowd go off and, you know, go and get a drink, go and get some food, which means that the next match on may not have that same level of excitement and noise. So we apply some of our Watson open scale technologies on that, which allow us to kind of look for some of that bias and drift. And then we use that for a number of different things. One, as I said, is to create automated highlights packages. So we then take those exciting points together, we apply some business rules. We don't want to have for example, all of the exciting points being from the lady who lost the match. We want to be able to tell a balanced story through it. So there's a little bit of logic you need to apply. But what it means is we're able to create entirely automated highlights packages. So something that may have taken somebody hours before can be done in a matter of minutes. And crucially as well, these are available literally just minutes after the end of the game. So it means that Wimbledon as a media organization themselves can get that information out, can get that data out super quick. The other way we do it is via a dashboard like this, which essentially is a way of filtering through particular events, particular games, highlighting which are the most exciting points. And you can kind of see down here, a rating of crowd cheering, those statistics, the player gestures, kind of creating an overall excitement rating. And this is the kind of dashboard that some of our Wimbledon colleagues use to kind of pull out some of those really exciting points. So this for me is a great example of how we apply AI in a really powerful way, which is taking a job which a human could do, but takes a huge amount of time, acting as a tool to support them in doing that, and therefore being able to do this for every match and every game. We can do it for wheelchair matches, we can do it for junior matches, just as well as we can do for the main draw as well, which improves the inclusivity of the game as well. So that's one of the use cases that I wanted to talk about. The next one I wanted to talk about is what Wimbledon knows as the greatest championship. So this was our result of the Wimbledon Championships being cancelled for the first time since the Second World War in 2020. So a hugely sad event, one which was absolutely not taken lightly by the club. But very quickly we got together with Wimbledon and said, hey, how do we celebrate tennis? How do we celebrate the championships in 2020? And we came up with this concept of the greatest championship. And to kind of set the scene for this, in 2019, we'd had a hugely successful year, millions of people engaged, all of those website visits we talked about, the AI highlights. And of course, everybody was predicting 2020 to be another bumpy year. An increase in excitement levels, an increase in engagement, and this was true across the whole of the, sorry, my slides are jumping around a bit, a whole of the sport. In reality, what we had was, somewhere around a 50% decline in kind of global sports revenues across the piece. Different sports reacted in different ways, clearly using classic matches and video footage from yesteryear was a theme, something we saw within the tennis. But of course, there was also the element of trying to engage with people in their own homes, to harness the stardom of their athletes, to be able to engage with people, to kind of keep people fit and well, very much focused also around that element of mental health, which was so important through the championships. So if I kind of move on to this, we had this challenge, how do we engage people? And we came up with this concept of the greatest championship. And this was really trying to essentially create a virtual championship based on some of the best matches of yesteryear. And what we wanted to do is we wanted to do that in a way which wasn't just, here's some video footage. So we created the whole sense of the tournament, the different rounds, the different matches progressing. We took those videos from yesteryear and we added all of that data analytics to them, which often we didn't have for those old matches, so that you could view them in a modern way. The challenge that we had was actually around then the video quality. So what we found is when you're watching a match from the 80s or 90s, the video quality is really, really poor. And it's more jarring when we've got so used to the quality of high definition video. And we looked at ways that we could improve the quality of that video. And of course, there are standard video editing techniques we used. But again, we'd been doing some research previously, which was focused around AI-based image enhancement and video enhancement. And I'm sure a number of people in the audience will be kind of familiar with this technique. But broadly, it's about using AI models, in this case, generative adversarial networks or GANs, where because of the nature of a Wimbledon video, Wimbledon has a very specific look, the shape of the bowl with the crowds, the green of the court, the white of the players. By training specific models, you can get a much better sense of much better enhancement than you can do with standard video. Now, in reality, as you might expect, as with every AI project and data analytics project, a lot of the hard work is actually at the front of this process. So getting those videos, splicing them together, removing noise, removing artifacts, and some of those pieces actually was a really, really hard challenge for us. What we then were able to do was to run those through that generative adversarial network, which we had trained by taking known good video and applying a variety of, if you like, degradation approaches to it. So you land up with two different videos. This is what a good video looks like. This is what a bad video looks like. And then you can actually train that generative adversarial network to learn how to take bad videos and make them look like good videos, to the point where it's very difficult for the discriminator to tell the difference. So we were able to do that. We were then able to add things like the AI highlights information, the crowd noise, and we were able to deliver those. And I've got a couple of examples of the video. How well sometimes these play over Zoom, we'll have to see, but let's give it a go. So this is from out in the 1980s, and you'll see this is a stiller, but I'll play the video. But you'll see the way that we've got the original video here, what you get if you run it through some standard software enhancement technologies, and then with the AI highlights and enhancements. And I think you'll see straight away, just even at the still level, the fact that the color is much deeper, much better. And I'll play this and I'll see how obvious it is to you guys to be able to see. Generally, it's the color, it's the sharpness.
40.
I'm not sure how much you're getting
So
of the actual video, but
This is 9.
we'll let it play. You may just be getting a few individual frames. And pause that again, depending on how well you can see that at your end. But essentially, we found that the sharpness improves, the color, fidelity and saturation improves, and this is true. Again, kind of taking something from the 1990s. Once we got to kind of the late 90s, we found that the video quality was typically pretty reasonable. So this is Becker Edberg in the final, and again the quality of the image, the colors and so on was something which was improved. And this is what allowed us to then build that experience of greatest championships, trying to take those videos of yesteryear and bring them into the current day. So let me just see where we're going. So I'm conscious of my time, so I'll kind of move on to the next area, which is really around what happened last year. The main thing which was hugely exciting was that tennis returned to SW19 in 2021. It's had a lot of support from the government in terms of classifying this as a pilot and kind of a test event, part of our research program. So we had less spectators in the ground, things like officials and players all in the hotels. And as you imagine, a huge number of health and safety pieces, which made our life much more difficult to deliver the championships, but was hugely successful. And there were two things which we did, which actually we've been working on over the course of the last kind of couple of years, but we were able to surface them for the first time at Wimbledon in 2021. The first was this concept of a power ranking, or a power index, as we're now calling it. And this is something which is complementary to the traditional ATP, WTA rankings. So I'm sure you're all aware, tennis players have rankings. The thing is that those are, first of all, across all of the tournaments, so across lots of different surfaces. They also have a 365-degree window, and that makes perfect sense for an ongoing ranking, because you don't necessarily want a player missing a tournament or having a bad tournament to kind of dramatically move them up and down the rankings. But what it does mean is that coming into something like Wimbledon, a player's ATP, WTA ranking may not necessarily reflect their potential on grass at Wimbledon. And what we were trying to do was to create a complementary ranking or index which achieved that. And to do that, we did a couple of things. Firstly was we did some statistical work. So we were started to look at, we used a 6-week window. The 6-week window is roughly the grass court season. So from places like Stuttgart and Eastbourne. And we used a couple of things. So we took those information, but also what we did was to use kind of the punditry. So what is being said about players in advance? So we use something, one of our products called Watson Discovery, which is essentially a natural language processing suite of technologies. So it's where we're able to take a vast feed of tweets, of blog posts, of mainstream media articles, ingest those all in. We're able to build a custom kind of ontology that understands tennis, understands the relationship between words and sentences, so that we can understand whether positive comments around players or negative comments around players. And we combine those things together to create this idea of a power ranking. So based on both what people are saying about the player, but also how the player is performing. And that allows us to do a couple of things. One is it allows us to provide a view of, who are the favourites going into Wimbledon based on that information. So this is something which is unique to Wimbledon as a grass surface. It also allows us to kind of create some interesting ideas around upsets. So where we, for example, have a different ranking for a player versus the WTA, doesn't really matter in which direction. What you see is kind of sometimes going into a tournament where actually into a match where, the rankings would predict one result, potentially we can predict another. And one of our active areas of research around this is how do we improve the actual prediction to win kind of coming out of this, and how do we understand how that works? And you'll see some of the graphics on the right hand side. In fact, if you go to wimbledon.com now, you can see some of these results as how the player rankings move up and down. And the other one was this idea of kind of pre-match insights. So what we wanted to be able to do was essentially create a summary in advance of the game. And this comes back to your casual tennis fan, somebody who doesn't really understand the game, being able to provide them with a real short summary of this match. And that includes elements around the power rankings and their ATP ranking. It includes some of those elements of, well, we understand that. So what are the comments in the press about, you'll see down the bottom right of the screen, what are people saying about the players in the press? What is the commentary about them? And also then what we do is we look at all of the head-to-head statistics. And there's always huge numbers of statistics. We use some of our more traditional data analytic techniques to understand, what are the most interesting ones out of them. And interesting is subjective. So in some cases, it's, where those statistics are furthest away from each other. Maybe it's down to, one player has a particularly strong serve or something like that. And that's an interesting thing we might want to do. And then we use some natural language generation techniques, using some open source technologies to take those and then just to put those into human readable sentences. And what that creates, as you can see on the right hand side, is a really nice kind of summary, a pre-match insight, combining some of the numbers, some of the information we have about that Watson Power Index, but also, as I said, what kind of information is out there in the media? What are the pundits saying about these players in the matchup? So that, in a nutshell, is kind of 3 examples of how we've been applying AI. We've been applying AI to the videos in terms of image understanding and information extraction. We've been applying AI to video in terms of actual video enhancement. And we've been applying AI to the written word, to understanding all of that information that's coming out in terms of the media, and being able to mine through that information, pick out the context, the relevance, the sentiment of it, to combine it all together, and also things like some of those natural language generation pieces. And it's true to say that I think we see this is kind of a really rich avenue of being able to use lots of non-numerical data in tennis to provide more of that insights. And with that, love talking about Wimbledon, more than happy to answer any questions. Yeah, thank you very much.
Thank you, Simon. So let's see if we have any questions here in the hall. Anybody wants to ask something? If not, I would have a question. I mean, you said at one point about making computers excited about tennis. Mm-hmm. What would that mean? I mean, how do you see that excitement?
Yeah, so I think that was a sort of a tongue-in-cheek way of describing what we've tried to do about giving a computer model which understands, if you like, what you or I would understand as exciting. And as I said before, we have some of that through, if I was watching a tennis match and I wanted to look at exciting things, I would absolutely want to look at break points, and I'd want to look at, parts of the game where perhaps the balance of momentum shifted from one player to another. Maybe somebody was 2 breaks up and somebody broke back, and all of that stuff we can do just by looking at the numbers. We can just look at the statistics that we have and the point trails and so on. But as I said, it was that recognition that watching tennis on the TV, being a member of the crowd, that the things that are exciting are the actual points themselves, and they are more than just the how fast was the ball or where did it go. Now, to actually look at the raw data and determine excitement is maybe a little bit of a challenge, but to be able to use the crowd as a proxy for that, the cheers, the excitement, the reaction of the players, for us was the extra dimension that we were able to add into it, and AI is integral to doing that.
Okay, so that means it is closer to the human excitement than the machine excitement. I thought maybe machine excitement would be rather coming closer to the perfection of the play. So if a player hits closer to the line, I believe the computer will get more excited than me, that I cannot see it by my eye, probably as the Hawkeye can see it.
Yes, yeah, you're right, and absolutely, what we are trying to do here is to create these experiences for the fans, and for us, it's how do we approximate what you or I would recognize as an exciting part of the game, because that's, again, not everybody wants to watch a 5-hour match of tennis. So how do you home in on what's the most interesting stuff in that 5-hour game?
Okay, and final question. I see that you were sort of rendering the old videos to get a better picture. How about rendering statistics so we can see if, what would be the match between Bjorn Borg and Novak Djokovic? If you can compare it through statistics using some artificial intelligence in order to make them, to keep them in the same, how would I say, in the same age.
So a very perceptive and kind of interesting thing. So I wouldn't like to say that this is something that we're going to do, for next summer, but it's absolutely an active area of interest, which is how do you do what you're saying, right? Which is, how do you take an element of players from different time periods, and there are different ways that we've thought about doing this. There's elements of, do you take the statistical information, do you take information about the match play, and do you render it through something like a sort of a Unity engine? Do you look to do this through, if you like, kind of the technologies of kind of deep fake style video, where you can take enough information in, you can build an AI model which can then potentially kind of create a visual representation of something which has never happened. But it's certainly an interesting thing. Interestingly made more relevant by the fact that it's actually 100 years centenary of Centre Court next summer. So we're interested in playing with ideas around, how do we do some of that historical look back over the last 100 years and sort of start to pick out, the most interesting pieces, and likewise to play them forward into the future around what tennis may look like in the future. So yeah, it's watch this space.
Simon, thank you very much for this presentation. It was great, especially for the tennis country like Serbia is.
Of course.
Well, guys, that was Simon Boyden, so we can applaud him a little bit.